So we have a postulate here, and it says that if two triangles share the following triplets of congruent corresponding parts, then the triangles are congruent. Now, actually, not all of these work, so I'm going to kind of hack off a couple of them. And we should have discussed this idea a fair amount in class before you reach this video, ideally. If you have two sets of triangles where the corresponding angles are congruent, that actually is not enough to guarantee that the two triangles are congruent. And here's my quick little mini idea. Imagine this little triangle has angles of 20, 70, and 90. Well, imagine if I drew that same triangle a little bit larger, where again it had angles of 20, 70, and 90. Well, corresponding angles are congruent. They are the same shape, but they are not in fact the same size. So angle, angle, angle does not guarantee that the two triangles are identical, otherwise known as congruent. So that one's out. Angle, angle, angle will never be used in one of our congruence proofs. There's another one, and I'm going to kind of put an asterisk near this. ASS, angle side side, or side side angle, does not always guarantee that the two triangles are congruent. So I'm going to kind of cross it out, but I'm going to put a stronger version in its place. And let's move some things around here. All right, so the stronger version of ASS, or SSA, that does guarantee that two triangles are congruent is a situation with right triangles. So let's say we have these two right triangles here, and we tell you, we give you this information. You might look and you might say, well, we've got two angles. We have ASS, angle side side. Oh, then the triangles must be congruent. Well, we've already said ASS doesn't quite work, but only in this case does it work. And it's really because there's that right angle right there. So I don't know if you probably have heard of the Pythagorean theorem. The Pythagorean theorem is going to force the third sides to be congruent because a squared plus b squared equals c squared. So only does ASS guarantee that you have two of the exact same triangle, or a unique triangle, if you will, is when there is in fact a right angle. So what we call this HL, or hypotenuse leg. This is the fifth and final postulate. All the other ones that are listed here that haven't been crossed out are totally acceptable for you to use in your proofs. But HL is the fifth and final one, and I consider that, in my mind, I think of that as angle side side, or side side angle, with a right angle. So if you look, this is ASS, and this is ASS. But the crucial thing is that angle that was given to you, maybe they said, you had some perpendicularity in your proof. You kind of explain that perpendicularity yields right angles, and all right angles are congruent. In these two triangles here, you have ASS with a right angle, so you could say these two triangles are congruent by hypotenuse leg. And if you know some vocab about right triangles, this is the hypotenuse. It's the side opposite the right angle. This is the hypotenuse. So you're given that the hypotenuses are congruent in the right triangles, and you're also given that a leg, or a non-hypotenuse side, is also congruent. So you have right triangles by the right angles. You're given that the hypotenuse and the legs are congruent. So we call this HL. So if there is not a right angle in your proof, they didn't give you anything with perpendicularity or anything like that, you would not be using hypotenuse leg. And be careful, ASS is not enough to guarantee the triangles are congruent unless you are given that you have a right angle. So here are your 5 postulates that you may use to guarantee that two triangles are in fact perfectly congruent. So let's say we were given the information here, and our goal is going to be to write a congruence statement and also to use one of the 5 postulates on the last slide. So first and foremost, that sounds like that'll be a far away from now. Let's first react to the givens. You must always mark up your diagram and put the appropriate tick marks on it. So they say AC is congruent to DE, so I'll put the same marking on both of those. They say BA is congruent to EF. They say BC is congruent to FD. So if you think about this, the three ingredients they gave us are the three sides of each triangle. Okay, so I can tell right away that I'm going to use the postulate side, side, side. We have three congruent side lengths here. So that's going to be the postulate that we'll use, and that one should be fairly obvious. Let me show you how to write a congruent statement. So what you do is you would say the two triangles are congruent by the postulate that we determined. So now you really need to be careful with your lettering. I'm just gonna make up the first one. You can always do that on the first one. So I'm choosing to go from A to B to C. Now you need to make sure that the letters match up or correspond on your second triangle that you're saying is congruent to it. So to go from A to B, you travel through this kind of greater than symbol. So we kind of have to look at our triangle, the triangle DEF, and see where that tick mark is. Okay, here's that tick mark. So we kind of have to go A to B to C, we're going through the greater than tick mark, and then to go to C, we go through the circle. So we have to go through the greater than tick mark and then the circle to have the same exact orientation. So we'd have EFD as our second triangle here. You must have this correspondence or matching up. And what this means is angle A corresponds with angle E, angle B corresponds with angle F, and angle C corresponds with angle D. You must always have that correspondence when you're carefully making your congruent statement about the two triangles. So use the tick marks and just check yourself. A to B to C, that goes through the greater than symbol and then the circle. Just like E to F to D goes through the greater than symbol and then the circle. So we've used the correct postulate and made a corresponding congruent statement based on our givens. So that was using side, side, side. So now we have the same diagram. We're given different things. We're going to write a congruent statement, and we'll figure out which postulate we have on our hands here. But remember, the first thing you do is you mark up your diagrams. So we're told that AB is congruent to DF. Okay. We have another side length, AC. I'll give that a different amount of tick marks. Is congruent to DE. Okay. And then last but not least, they say that angle A is congruent to angle D. So we mark in all of these components, and we notice, I'm just going to kind of label them. Well, that's a side, we've got some angles here that are congruent, then we have two sides that are congruent. Now you can very clearly see that the angle is in between the two sides that are corresponding and congruent. So you can already kind of see the postulate, side, angle, side. Side, angle, side. So it's very, very important. The A is in between the two S's, so the appropriate postulate here, one of the big five from that first slide, is side, angle, side. That's enough to guarantee these two triangles are congruent. So then we'll also need to make our congruent statement and make sure everything matches up. So again, just make a choice. For the first triangle, let's do triangle CAB. So if I'm going to go from C to A to B, C to A is going through the double tick marks, and then to go to B, you're going to go through the single tick mark. So E going through the double tick mark, and then the single tick mark, we would call this triangle EDF. If you were to label it in any other way, that would be incorrect. You need to have that correspondence. Okay, so we have our congruent statement and we have our postulate. So based on those givens, these two triangles are congruent by side, angle, side. So in this example here, I just kind of pre-did it a little bit in blue at the top here, and I made my congruent statements based on the given diagrams. So based on the diagrams, you can very clearly tell that we are given a couple of sides that are corresponding and congruent, some angles that are corresponding and congruent, and then some more sides that are corresponding and congruent. So notice how the angle is in between the two sides. So the postulate here would be side angle side by side angle side, these two triangles are congruent. So now in this example, we're going to do the same thing. We're going to look at the given diagram, maybe find out some extra information, and then in the end our goal is to write a congruent statement based on the given information and the postulate that led us to believe that the two triangles were congruent. So first and foremost, you've noticed they've only given us two sets of corresponding parts here. We have a couple of corresponding angles that are congruent and corresponding sides that are congruent, but every postulate requires three ingredients or components with congruent sides and or congruent angles. So you should think back to the first video that I did with you guys. I noticed that there are in fact two lines that intersect. When two lines intersect, vertical angles form, and vertical angles are congruent. So I'm not making an assumption here. I'm using the information given to make a logical deduction. So we won't give you the fact that vertical angles are congruent, but you just have to know based on the orientation of the diagram. So that's that third and final component of information here. Now you can look and you can say, okay, these are a couple of angles that are congruent, corresponding angles congruent. We've got a couple of corresponding sides that are congruent, and then we had our vertical angles congruent as well. So the postulate should jump out at you. Notice how there's a side in between the two corresponding angles that are congruent. So our postulate here will be angle side angle. And we can make our congruent statement. I'm just going to kind of make up the first one. We'll do PSR. And now P, of course, is congruent to O, so that'll be our first letter in the second triangle. PS corresponds with OS, so we'll go to S next. And then angle R corresponds with angle T. They don't have any tick marks there. So we now have our congruent statement and we figured out our postulate. So the key was right here that vertical angles are congruent. That was crucial. You'll look for that a lot in your proofs. On this example, again, we're only given two sets of corresponding sides that are congruent. So now we just have to kind of think. There aren't any vertical angles here. So what else can we do? We don't have two lines intersecting, no vertical angles. Well, I noticed that the bottom triangle KLB, and the upper triangle KMB, they both shared side KB. Well, so you'll think this is kind of silly, but you can actually say that side KB, since it's on both of them, wouldn't you agree that anything is congruent to itself? Okay, well, side KB is congruent to side KB by the reflexive property. I should not have capitalized that R, but I'm going with it. So that's another thing. Based on the orientation of the diagram, you're just going to have to figure it out. If two triangles share an angle, or they share a side, like there's this overlap, then that angle or that side is congruent to itself by the reflexive property. So now, pretty clearly, all three sides are corresponding and congruent. So then we'll just worry about the orientation of our congruent statement here. So I'm going to go KBL. I always make up the first one, and then the second triangle I'll have to have in the same orientation. To go from K to B to L, you go through the X and then the triple tick. So we're going to go through the X and then the triple tick here. So we'll do BKM. And this would be the kind of thing you would want to pause me as I'm telling you this and see if you can make the congruent statement fill out that second portion and just make sure that it aligns with what I have. So now we have our congruent statement. The two triangles are congruent by side, side, side. Now in general, this will be the last line of every one of your proofs, what we're kind of doing here. In this example here, I'm not giving any letters or anything. Let's just say the postulate that we would be using if we were to prove that these two triangles are congruent. Well, if you notice the ingredients you're given here, you're given an angle, an angle, an angle, and some corresponding sides that are congruent. Well, this one might be a little weird, but if you think about it, the middle letter, if you were to like kind of walk along these triangles, if you started here and then walked along here, if you started here and you walked along here, the middle ingredient is a corresponding angle that's congruent. Now, the postulate for this sort of triangle is in fact angle, angle, side. And the reason why that is we wouldn't call it angle, side, angle, because if you started here and walked along this side, we are not told anything about this side. There's no tick mark here. There's no tick mark here. So if you walked from here to here and then went down to this side, you skipped an entire side in determining your postulate. So you don't really want to go this way. That's going to be incorrect. Instead, you'll go towards the next bit of information. So go from this angle to this angle, and then towards your next bit of information, angle, angle, side. And what's cool is AAS is actually a word in Scrabble. It's the plural of rough, cindery lava rocks. So tell your earth science teacher you learned about that on your geometry video. So this is the correct postulate here. Now on example 6, we're only given one bit of information here. Now we know we need 3 sets of corresponding parts to use a postulate to determine that if the triangles are congruent. But in this situation, we're only given one bit of information. But actually, by the diagram, right now you should be raising your hand in your mind and saying, "Oh, look at the orientation of the diagram. I know that BE is a line that intersects with AD. Therefore, when 2 lines intersect, vertical angles are formed, and vertical angles are congruent." So you get that for free in the diagram. You have to use your spider sense to realize and recognize that. So now actually we're given 2 bits of information. And now in part A, in order to prove that the 2 triangles are congruent using side, angle, side, the question is, what ingredient would you need to be told? What corresponding ingredient would you need to be told is congruent? So for side, angle, side, let's see. Well, we have a side here. The angle is in the middle. Why, we would need this side to go with this side. That orientation is very, very important. Side, angle, we would need this side. So we would need BC to go with, so side, angle, we need this side. Start in the given side. Side, angle, we would need that to be congruent to side CE. That would be the missing ingredient to use the postulate side, angle, side on this diagram. Now similarly, what if we wanted to use the postulate angle, side, angle? Well, we're given an angle and a side. We're given an angle and a side. We need the angle, we need the side now to be in the middle. So this side and this side need to be in the middle. We're given an angle, we've got a side. So the other angle we would need is angle A. That would have to go with, angle A would have to go with, let's see, angle, side. Well, it'd have to be this angle so that the side is in between them. So that would have to be angle D. Okay, so we can kind of ask the questions forward and backward. And you really have to have your 5 postulates down and memorized. Last but not least, this is for you. You need to write a congruent statement with the correct postulate, just like the examples that we've done before. Make sure your answers kind of look like so, and make sure you're marking in your diagram. Look for things like the reflexive property or vertical angles being congruent, because you might feel like there's not enough information in these diagrams, but if you look closely and maybe look back at the video, you'll find that there is enough information. So make sure you copy this down and figure it out.